Sustainability has to be considered throughout the life cycle of the project, and I mentioned even after the life cycle. You have to keep in mind when we dispose of the product, when we dispose of the material, what will happen. Okay, and I gave the example of plastic. So it's a very durable material, very flexible, easy to work with, could be made strong as well, but in the end, the disposal is a problem. Okay, so it's not sustainable even if it lasts for 100 years. Even at the end of the project life cycle, it's not sustainable because I cannot dispose it, and then I have to look for how to recycle it and so on and so forth. Okay, this is where I stopped. This is like what I discussed in the last minute, basically. So sustainability has a connection to ethics as well. And I mentioned ethics something which you have to like. It's not a professional responsibility. It's your responsibility as a human being. Okay, so if I see something unethical, I'm the site engineer or I'm the labor on the site. It doesn't matter. Okay, I have to do something about it. Okay, or at least I have to take up this matter to the concerned person or to the concerned organization. Okay, so ethics is not something which you say that the engineer will take care of it or the boss will take care of it. It's everybody's responsibility. So when we say sustainability is an ethical responsibility, ethical obligation, that means you have to take into account sustainability in in any role in the project. Okay, in any role which you are doing in the organization, you have to take into account the sustainability aspect. So you must be looking to protect public health and safety. You have to make sure that you are not doing anything harmful for the environment. You have to use the resources responsibly, and I gave the example of electricity, water. Okay, so even at your homes you cannot waste these resources. Okay, so because it's harmful for sustainability of the nation. Okay, and consider long-term societal impacts. Okay, what impacts it will have on the job market, what impacts it will have on the product cost and so on and so forth, and what impacts it will have on the people. Okay, maybe it's a very good design but it produces a lot of noise, so that is not good for the quality of life of the people. One of you mentioned about quality of life, right? We have to improve the quality of life, so this is your social responsibility. So ignoring sustainability will violate uh, ethical rules. Okay, and these ethical rules incorporate environmental damage, unsafe infrastructure, okay, and burdens on future generation. Okay, so these are all considered as part of your ethical duties. Okay, when you will go into design courses, maybe you have already taken or started talking about the codes, the standards which are used in design. So when you will do concrete design, steel design, highway design, uh, pipeline design, there are certain codes and standards which you have to follow. Okay, so this is part of your professional expectation. Okay, people expect you to follow these standards and codes. So when you are a design engineer in Bahrain and you provide a design to your client, the client expects that the design meets the Bahraini code and standards. Okay, and it will be approved because you have to get the approval as well. So when the design goes to the ministry for approval, they will approve it because it's not violating any code or standards. Okay, so in most of the courts, uh, the public welfare is the highest priority. Okay, uh, the benefit to the public is the highest priority in all the courts. Okay, so nothing can be negotiated for public safety. You cannot say I will save cost but make it less safe. It's not, or it will be harmful for the public. You cannot do something like this. Okay, your design should be competent and responsible. Competent means it should be fit for purpose. Okay, competent means it should be uh, fit for purpose. Okay, so if I have a design which is for a classroom, then should be able to provide enough space for the classroom, hold enough load which is for the classroom, okay, have good sound quality, okay, provide ventilation and so on and so forth. If I'm doing it for an industry, okay, then maybe I need stronger slabs, stronger beams, because the machinery will be very heavy. Okay, so this is what we mean by competent. Okay, and responsible means that uh, it will it is according to the needs of the client. Okay, it is according to the needs of the client. So if the client has asked you for something to be incorporated in your design, you already did that. Okay, the client asked for the window should be on the higher level. Okay, the door should be big enough. Okay, and I mentioned the responsibility, the expectation aspect, that the you are responsible for following the codes. Okay, so the standards. Okay, so whatever the local and the international standards are, you have followed them. So you have followed the needs of the client as well as the rules and regulations of that part of the world. And you have to consider the long-term impacts. So the code also ensures that whatever you are designing will sustain for longer terms. Okay, it will be a durable design. Okay, so uh, public welfare means safety. Responsibility and competent design means that you are following the rules and the regulations and the needs. Okay, and long term means your design is durable. Okay, and responsible also means that you are fulfilling the environmental responsibility as well. Okay, so whatever your responsibility is towards the client, towards the government, towards the people, you are following it. Okay, so it may not the you don't just look at the safety of the public, that okay, the structure will not fail. Yes, the structure will not fail, but maybe it is causing some harm to the environment. Okay, so it can still bear the load, but it is harmful for the environment. Okay, so responsibility means that you are considering environmental responsibility, social responsibility, and so on and so forth. Okay, so what is the connection of codes and sustainability? How codes are relevant to sustainability? So uh, uh, the the codes provide you environmental regulations. Let me give an example. When you are designing a water treatment system, okay, a water treatment system. So for that water treatment system, there are codes available that before the water goes out of the treatment plant, its pollutant level should be this much. Okay, so these are environmental regulations. Okay, similarly, when you do your construction, when you finish your construction job, you will have some waste material on the site. So you cannot dispose this waste material anywhere you want and anyhow you want. Okay, so the environmental regulation, the codes will tell you that you have to take this material to this place and you have to dispose of in this manner. Okay, that will be taken in trucks, the trucks should be covered, it will be taken to this side, so all these things. Okay, so these are the environmental regulations which are given in the codes. Okay, safety standards are given. If your load is 2 megapascal, the code will give you how much safety factor of safety you should take, how much you should take into consideration the risk aspect, and these things. Okay, and professional accountability. Okay, the course also make sure that you are, whatever you're doing is, you are professionally responsible for it. Okay, so if any harm reaches to the client or to the environment or to the country, they will know that this person is responsible. So the courts force you to be responsible for your design. Okay, so sustainable design, so we discussed sustainability is linked to economy, environment, society, and as well as your technical codes. So a sustainable design is both technically sound as well as ethically responsible. So sustainability has to be considered as a top priority because it is the main design constraint. Okay, it is a thing which will bound your design. Okay, your design should be under these limits. So the limits are provided under the approach of sustainability. It is your professional duty as well as your ethical responsibility. Okay, and then it becomes, because it is also linked with the code, so it becomes your key engineering principle as well. Okay, and you have to take into account the long term consequences. Okay, moving on. So the quiz will be up to this lecture. Okay, so there are three slides included in the quiz. Okay, so now I'm beginning with the new one, the new topic, which is specializations and civil engineering, and the role for each one of them in the society. So we have already discussed the role of civil engineering in the society. We already discussed that. Somebody remembers what is or why civil engineering is important for the society? What is the role of a civil engineer for the society? Tell me. The role of civil engineer for the society, or why civil engineering is important for the society. Both are interrelated. Yes, civil engineers provide infrastructure. Yes. What else? Anything? Anybody else? Yes. Anybody else has any other idea? Yes, anyone else? Why civil engineering is important for the society, or what a civil engineer does for the society? The main thing is, yes, infrastructure. But anybody wants to say anything else? Making life easier. Yes. Making life easier. What else? Ensuring safety of the people. Yes. Okay. Let us see. It's just a recap of what we have said earlier. So we directly serve people and society both. So we are giving products or projects which affect individual people as well as the entire society, because we deal with infrastructure. Okay, so infrastructure, uh, like buildings, can be used by specific people, and there is infrastructure like road, water system, and bridges, which is used by the entire society. Okay, so we play our role in public safety, comfort, and quality of life. Okay, all these three things you have already said it in your responses. So well done. So in these slides, waste and pollution control, yes. So that is related to quality of life. Okay. So the objectives of these slides is that you should have an idea about what are the main branches of civil engineering. Okay, and you should be able to see their role in the society. Have a little bit of understanding of the society, of these specializations and their real world application. Okay, and you should be able to connect this in the Bahraini context as well, like how a specific specialization will be affecting the people or the society in Bahrain. Okay, so we are going to go through these aspects in these slides. Okay, so the first thing is, you see the specializations there. Okay, structural, geotechnical, transportation, water resources, environmental, construction, and project management. Then you see a picture here on the right hand side. Okay, if you compare between the text and the picture, you will see a couple of extra things here. There are a couple of extra things in the picture. Can you identify them? What are the extra things which are mentioned in this picture but not in the text? Yes. What is specializations you see in the text but not in the picture? Oh, sorry, it's the other way around. What is specializations you see in the picture but not in the text? Tell me. The good thing about Blackboard is if you send me a message, I can like hear it. That's a very good thing. Yeah. Anybody can detect? It's like a game, right? Detect the differences in the picture. Okay. Earthquake. Okay. Well done. Earthquake. Yes. There's another one. There's one more. So there's earthquake engineering written there in the picture. Okay, coastal engineering, yes. Okay, so yes, well done. Earthquake engineering, coastal engineering. Okay, earthquake engineering in many cases is considered part of structural engineering. Okay, earthquake in many cases becomes part of structural engineering, and coastal engineering can go with water resources or environmental engineering. Okay, it can go with water resources or environmental engineering. So these are the extra things which you see in the picture, basically sub branches. Okay, so it depends upon the context and people in that region. Okay, so for example in Bahrain, we alhamdulillah we don't have the earthquake problems. Okay, so we don't need like a separate specialization for earthquake. Okay, so if we need something in any particular point, we ask just a structural engineer to have a look at it. Okay, because normally it will not be required. And coastal engineering, yes, we need it, but we don't have it. Okay, it depends upon the availability of the people as well. So in UOB, for example, we even combine water resource and environmental engineering into one as well. Okay, so these are combined into one as well. Okay, so the fields can be combined or they can be broken into different parts depending upon the situation in your region and the availability of the specialists. Okay, so let us discuss these fields one by one. Structural engineering deals with structures. Okay, a structural engineer will do the analysis and the design for buildings, bridges, and any other structure. Okay, so a structure is something which takes the load basically. Okay, so when we say structural engineering, it means that you design the load bearing mechanism of that thing, of that project. Okay, so structural engineering deals with the load bearing mechanism. Okay, how your building, how your bridge will bear the load. Okay, so when the load will be applied, any type of load will be applied, how will it go from or how will be transferred from one member to the other member. Okay, what points the transfer will happen and how the load will be distributed and so on and so forth. So all these things are considered part of structural engineering. Okay, so anything to do with the load. Okay, anything to do with the load, application of the load, bearing of the load, okay, transfer of the load. Okay, so structure engineer deals with anything to do with the load. Okay. Then we have geotechnical engineering. So geotechnical engineering is basically the study of soil and rock. Okay. We know any structure, which you have on the globe, eventually the load of the structure goes onto the soil. Your structure is on the ground, right? At some point it comes in contact with the ground. So your ground is the ultimate support mechanism for you. Okay, it is a final support mechanism for your structure, for your product, or for your building. Okay, whether it's a bridge, whether it's uh, a building, whether it's a mall, okay, anything. So eventually the load cannot be dissipated in the air, right? It has to be finally transferred onto something. So the final destination of the load is the soil or the ground, and the ground is either made up of soil or rock. Soil means it's loose material, rock means it's hard and compact material. Okay, so you can see the two things over here. So this type of thing is a soil and this type of thing is a rock. Okay, and you can find both these in the natural ground. Okay, any of them or both of them in the natural ground. So geotechnical engineering again deals with the load, okay, but not the load of the structure itself, but how the load will go from the structure to the ground. Okay, so and can the soil bear it or not? Okay, so the load bearing of the soil is depends upon its properties. Okay, if it is soft soil, it can take a small amount of load. If it is hard rock, it can take more load. Okay, so you have to make sure that your building is safe and stable. So yes, your building, your bridge can be safe and stable over the ground, but it may happen when the load is transferred to the ground does not have enough support, the ground does not have enough strength to take the load, and then you can start having problems from that point onwards. Okay, from under your structure, not from in the structure, but from under the structure. Okay, and one of the major problems when you do not take into consideration the ground conditions is what they call as the settlement of the foundation or the settlement of the building. Okay, so it starts to what you call uh, go into the soil. Okay, so you have your uh, foundation on the ground. I believe I can make it here. Yeah, so let's say this is your soil and this is your foundation. Okay, the load goes, if the soil is weak, your foundation will start to sink into the soil. Okay, it will start displacing the soil, it will go into the soil. Okay, and now it's not only a foundation. On top of the foundation I have my building, right? So when the foundation starts to sink in, when the foundation starts to settle, we call it settlement. Okay, when foundation starts to go into the soil itself, when soil is displaced, our foundation starts to go into it, we call it settlement. Okay, so this settlement will destabilize the entire building. So you start to see the cracks and you will start to see building is deforming and so on and so forth. Okay, so this is all uh, considered part of geotechnical engineering. Okay, then we have transportation engineering, okay, which is my specialization as well. So it deals with the planning, design and operation of transportation systems. Okay, transportation systems can be roads, okay, it can be airports, can be ports, railway lines, okay, bus networks, metro systems, Okay, bridges are also part of it. So but the when so there's a difference when a structural engineer designs a bridge and when a transportation engineer is looking at the design of the bridge. The structural engineer is looking at how the bridge will take the load. Okay, a transportation engineer is looking at the bridge, how it will benefit the traffic. Okay, so they are designing from different perspectives. Both of them are required. Okay, so in one design you may need multiple specializations, just as the case of a bridge. Okay, so you are designing a bridge, so a transportation engineer or traffic engineer will tell you what this bridge will do to the traffic. Okay, and how much should the speed limit, how many lanes you need. Okay, the things which are related to the traffic itself. The bridge engineer, the structural engineer of the bridge, will tell you uh, how strong, how we should make the bridge strong to take the load of the vehicles. Okay, and if there are any other loads, then how the structure should be made to take those loads. Okay, so a transportation engineer is basically looking at the movement of people and goods, okay, from one place to the other. It can be done on through the roads, can be done through airplanes or ships or buses or trains or whatever. Okay, even pipelines as well. uh, what else? Yeah, and you have to make sure that you consider the safety aspect as well. So again, safety could mean structural safety, okay, or it could mean the safety of the drivers. Okay, so you may have a bridge. The bridge is strong enough to take the load, but on the bridge you are having accidents. So the bridge is structurally safe but not safe for driving. Okay, so again, you have to look at safety from different perspectives as well. uh, in the curriculum, in our curriculum, at UOB or even in other universities in the kingdom, the curriculum mainly focuses on the roads. Okay, we are mainly focusing on the roads. Okay, but as you know, the things are changing. We have now new systems which are in the pipeline, new airports, new bus systems. You have heard about metro system. Okay, the Bahrain is trying to expand economically as well. It was trying to become economic hub. So its ports and airports they also have importance. Okay, so we need people who have a specialization in these fields as well. So you have to look into when you are considering your future in this field, you have to look into how I can serve the society better in futuristic terms. Okay, not what is happening now, but what where things are going in future. So you have to look at the future plans as well. Okay, and because my field, so that's why I'm emphasizing so much on this. Okay, but the same is true for every field. I may not know the future trends in structural engineering or geotechnical engineering, but you get the idea. Okay, when you're deciding your field, you have to look at the future developments in your country, in your area, and so on. Okay, so then we have water resources engineering, which deals with the planning, design, management of water systems. Okay, water systems can be for drinking water supply. Okay, water which you use. Okay, the tap water. It can be for the transfer of wastewater and its treatment. Okay, so we have uh, wastewater generated from our kitchens, from our toilets, and so on and so forth. So that wastewater needs to be shifted from our facility to a treatment plant, and from the treatment plant it is treated and then it is disposed of in the environment. Okay, so this is where the environmental regulations come into play. Okay, so in Bahrain we have the environmental council. I forgot the full name, sorry for that, but it is called environmental council of something. Okay, I remember that much. So there's the environmental council which gives you the standards for these water systems. Okay, and other environmental aspects as well. So the point was that once the water is treated, the wastewater is treated. Okay, so who tells us how much to treat the wastewater? Okay, you cannot, in most of the cases, you cannot make the wastewater usable, like usable for drinking and so on. Okay, so I consumed water that became wastewater, and then I'm treating it. So in many of the cases, we do not do the treatment to so high level that it becomes reusable. Okay, uh, so to what level do we treat the wastewater? So those standards are given by the Environmental Council. Okay, so that after treatment, when you dispose of the water, it will not harm the environment. Okay, so we just treat it enough to be disposed of in the environment, but not more than that. Okay, then we also deal with the water resource engineering also deals with storm water drainage as well, basically rainwater. Okay, rainwater. Now this is a neglected field in Bahrain because we have small amounts of rain. Okay, the rain does not happen throughout the year, and usually it happens in a very small amount. Maybe for a few days in the whole year we have heavy rain. Okay, so the stormwater drainage on most parts is not considered economically feasible to have a good. We have the stormwater drainage system with the gullies and with the with the disposal onto the land and so on and so forth. Okay, but on few days in the year you will see that the system is having too much water. Okay, so what should be the capacity of this system? The system which is carrying rainwater, and again where this rainwater should be disposed. Okay, can I just should I just let it go to the sea in our case because we have a sea? Should we just dispose it to the, or should we just dispose it to empty lands? We do it. Okay, in many areas in Bahrain, they have these small plots where the drainage or the stormwater is being disposed, and then they let it just be there until it evaporates. Okay, so uh, there are many areas in Bahrain where you can see this happening. So and when there is heavy rain, they pump water from the roads, and they put it on these land, these plots. Okay, away from the roads. So the main thing here for stormwater drainage is the very important aspect is you need to get it away from the roads. Okay, I already gave this example a couple of times. What my teacher used to say, there are three factors for road damage, that is water, water and water. Okay, so water accumulation, the rainwater accumulation in the roads is very dangerous and harmful for the roads, and it can be dangerous for the drivers as well if they are driving when there is water on the road, the wet pavement. Okay, water on the pavement affects the braking. So stormwater drainage, going back to the point, you need to know how much rainfall you have. You need to know how you will collect water and what you will do with this water. You will just dispose it, or you can use, it's rainwater basically. It's very clear and pure rainwater. So if you can collect it, you can reuse it. Okay, so it's part of a very sustainable means of water source. Okay, uh, anybody knows what is the source of clean water in Bahrain? Like from where do we get clean water in Bahrain? Anybody knows that? What is our source of clean water in Bahrain? The water we use, where are we getting it from? It's in the news basically. That's why I'm asking. Yes, water source in Bahrain. Desalination, yes. Okay, so this is in like in news for a couple of days. Okay, the desalination plant being under the hit and so on and so forth. So desalination process, takes energy. Okay, the desalination plant itself is a heavy process. Okay, so yeah, sea, yeah. So we take water from sea, we desalinate it, and then we use it. So it's a energy intensive process. Desalination is an energy intensive process, and the plant also needs a space and whatnot. If you can somehow utilize other sources, then it will reduce pressure on your desalination plants. Okay, reduce pressure on your main source. Okay, so rainwater or any other type of water. Okay, we have couple of book chapters, we are trying to publish them. So once it is done, you can have a look at it. So there are many other sources which can be used as an alternative to the desalination process. Okay, then we have environmental engineering, and as I mentioned earlier, in many cases the water resource is considered part of environmental engineering. So the main focus of environmental engineering is protecting human health and environment. So you have to take care of the wastewater, the control the pollution from civil engineering projects, and manage the waste. So managing waste means you again, whenever we say waste, wastewater, solid waste, it basically entails three things: collection, treatment, disposal. Okay, there are three important parts of waste management, which is collection, treatment, and disposal. Okay, treatment can also means recycling. Okay, treatment can also mean recycling. Then disposal means using it again, reuse. Disposal will mean I will reuse it after recycling. We don't call it reuse, but you get the point. After recycling, I can use it. Okay, so wastewater, solid waste. Okay, so how to collect it, treat it, and use it or dispose it. This is all part of environmental engineering. So environmental engineering is broader than water resource. Okay, it's broader than water resource, and the water resource engineering also had the aspect of stormwater, rainwater harvesting, and so on. Here in environmental engineering, we also consider controlling the pollution of our projects. Okay, the pollution aspects of our project. So pollution can be because of your mixing process, because of maybe cement production. So all these things. Okay, so this is part of environmental engineering. And another thing is conservation of natural resources. Conservation of natural resources. Okay, so when we talk about concrete, okay, the most commonly used material in civil engineering is concrete, right? So in concrete, uh, we are using uh, many natural resources. Okay, so concrete is made up of what? Tell me. If you want to make concrete, it is made of what? Aggregate, cement, water, right? So water is a natural resource. Aggregate is also a natural resource. Okay, and aggregates involve the aggregate as well as sand. Okay, sand is can also be considered part of aggregate, or you can call it sand. So these are natural resources. So if we reduce the use of concrete, we reduce the use of natural resources. Okay, now why we want to save the natural resources? Because every time you use a natural resource, you are uh, changing the natural equilibrium. You are disturbing the ecosystem. Okay, so there's a water body somewhere, and I take uh, large amounts of water from it for my use. When the water level decreases from that water body, it will affect the environment around it as well. It will affect the water table in the soil. It may affect the species which are living there, which take water from that water body, and so on and so forth. Okay, so same thing with the aggregates. For aggregates, you do mining. Okay, they call it quarrying. Mining is okay very deep, but quarrying. Okay, so for aggregates, you do the quarrying. Okay, so when you are doing the quarrying, you are disturbing the natural soil. You are taking the natural material. Okay, so maybe there are species living there and so on. So you are disturbing those things as well. So that's why we try to reduce it, so that disturbance to the ecosystem is as less as possible. Okay, so we look for uh, techniques to reduce the use of natural material. Okay, then we have construction and project management. Project management is broad, construction management is a specialized field, which is project management for civil engineering. Okay, so project management you have in IT, in chemical, in mechanical, all these fields have project management field. When you say construction management, it means project management for civil engineering. Okay, but the broad field is construction and project management. So in construction and project management, we do planning, execution, and controlling of the projects. Okay, now what you see here, planning, execution, controlling. In the other fields which I showed you in the previous slides, structure, geotechnical, uh, transportation, and water resource, and so on, there was a term which is not here. Okay, in all of them there was a common term which is not here. Can somebody guess that term? What was the term which I showed you in the previous slides for other fields, but that term is not here? So it is saying it involves planning, execution, and controlling. So it is missing something here, which I showed you in the other fields. What was that? What is that? What is the thing which is not included in construction management, but it was included in structural, geotechnical, transportation, and water resource, and so on? What was that term? Yes. What is the term which is uh, present in the other fields but not in construction management? Anyone? Have a guess, no problem. Design, yes. Very good. A design is not there because we are talking about management here. Okay. Another thing which you may not notice in the name. So even in the name there's a difference. We are not calling it, although we can call it construction engineering. We are calling it construction management. We said environmental engineering, structure engineering, transportation engineering. Okay. So whenever we put the term engineering with it, it has to involve some sort of design. But management by itself is without design. Management by itself is without design. So you don't see the term design here. Okay. So that's the main difference between management and construction management and the other fields. Okay, those are engineering. So in engineering there has to be design. Okay, so this is engineering without design. Okay, so we are doing the planning, we do the execution, we do the controlling. Controlling means what? You make sure that everything is according to the plan. Controlling means making sure execution is according to the plan. Okay, so controlling is Alignment between execution and planning. Controlling means alignment between execution and planning, making sure execution is according to the plan. Okay, so for a construction project, there are four main aspects which this professional has to consider: time, cost, quality, and safety. Okay, for any construction project, a manager has to balance between these four aspects: time, cost, quality, and safety. Okay, for example, if you have gone to any site visits, you may have seen they give you a lecture before you enter the site. They give you a lecture. Okay, that you should do this, you should not do this, you wear the helmets, you wear the safety vest and the safety boots and whatnot. Okay, uh, now in your case they may give it to you or they may ask you to bring it, but for their own staff they have to spend money to give them helmets and boots and vest. Okay, so this takes money. This increases the cost basically. This increases the cost. And every time the labor comes onto the site or the staff comes onto the site, he will first go and he will prepare himself with these things. Okay, in some cases they will ask them to wear the gloves as well. If they are using drill or any electrical equipment, they'll ask them to wear the gloves as well. Okay, so preparation, now you can imagine there could be 30-40 people working on the site and all of them have to do this preparation. Okay, wearing gloves and goggles maybe in some cases. So this preparation takes time. So the safety equipment takes cost and preparation takes time, and you have to bring it to the site and so on. So you are increasing the cost, you are increasing the time, but at the same time it is important for safety. Okay, so you now the point was a manager has to balance between them. Okay, he has to balance between them. So how do I balance? Yes, I need safety, but that doesn't mean that all 200 people on the site will be wearing a goggle and a glove as well. Okay, yes, what is the minimum safety requirement? Helmet, vest and boots. Yes, this is enough for everybody. Okay, so I will have maybe 200 of these things, but I know only 10 people are working on the equipment which needs these goggles and gloves. Okay, so I will not bring 200 goggles and gloves, I'll bring 10. Okay, so I'm balancing, I'm trying to balance, okay, with my cost and with safety. Okay, same thing with the quality as well. Okay, so I can use a material which is of very good quality. Okay, it will give very smooth finish, it will last for 200 years, but now it will cost me double. Okay, so I may go for a medium term option, a mediocre option, which may last for 50 years, and I may have to spend maybe 1% extra on the finishing, and that's it, but the cost will not be doubled. Okay, so the balance between cost and quality. Okay, so the point is a construction manager is balancing, he is not trying to maintain cost, quality and time and safety at the same level. It's not possible. Okay, so you have to see how much I can spend to have reasonable, to finish the project with reasonable quality, with reasonable time and with no problems of safety. Okay, so this is the job of the construction manager. Okay, another important job for construction manager which creates a lot of problem when it is not done properly is the coordination, the communication between the stakeholders of the project. Okay, in a construction project there are many stakeholders or parties involved. Okay, in a construction project there are many stakeholders and parties involved, such as what? Tell me, who is involved in a construction project? Yes, who are the people or organizations involved in a normal construction project? Yes. If you have a construction project, who are the people who will be part of this project? Like in general. Obviously, I'm not asking for names. Owner, for sure. Owner can be a person, it can be an organization as well. Okay, owner can be a single guy, okay, or a married guy, but a guy, but it can be an organization as well. The architect, yes. Engineer, engineer, which engineer? The labor, the client, or the owner, same thing. Design engineer, yes. There's another engineer involved. Who is that? Workers, project manager, contractor, yes. Okay, so good enough. More contractor, yes. Okay, so good enough. So you can see there are many stakeholders involved. Okay, the names which you have given here. So yes, there can be main contractors and other contractors as well. So there's the main contractor doing the job. They're the contractor for labor. They're the contractor for materials. Okay, so and there can be one owner. The owner can be the whole organization. It can be Ministry of Works, for example. Okay, so Ministry of Work doesn't is not one person. Okay, so and they get approvals from many levels. Okay, so whatever you are saying will be going to one person, then a committee, then the big boss, and what not. Okay, so the another important job for a construction manager or a project manager is the coordination, communication. Okay, so now you can imagine what will happen if the manager himself is not a good communicator. Okay, we have talked in the first topic the importance of communication. Okay, so if you now just a side note here that project management, construction management is considered the most in demand job all over the world from civil engineering discipline. From the civil engineering field, the management is the most in demand. Okay, whatever you do, you there are more chances you will end up in the management side. Okay, rather than the other fields, especially in this region, GCC. Okay, here uh, structure engineer, water resource engineer, they have scope, but the scope for management managers is more usually, especially in GCC. So going back to the point of communication. So an important job for the manager is to coordinate between the parties. And if the manager cannot communicate well himself, then what he will communicate to the other parties? How will he deal with so many people? Okay, and even if you are not the manager, let's say you are not the manager is somebody else, you are the designer. Okay, or you are from the clients or from the contractor side, or you are from the client side, you are in working Ministry of Works or Ministry of uh, urban planning or something. Okay, uh, the manager will come to you and he will ask you what do you want and so on, and you cannot communicate your needs, you cannot communicate your issues, you cannot communicate your problems. Okay, so communication is very important here. In the construction projects, communication is very important. Most of the failures happen because of the communication problems. Okay, so now we will look at some examples of these fields which are related to Bahrain. Okay, and how these fields are working or can work in Bahrain. For example, structural engineering. Okay, so basically structural engineer, as I told you, is dealing with the loads, right? So if the building, if the structure cannot bear the loads, it will fall. If it has a risk of falling, that means it is unsafe. So a structural engineer directly deals with safety. Okay, so he is taking care of the safety aspect directly. So Bahrain, as you know, has many high-rise buildings, uh, in Manama, in Sif and Jufair and many other areas. Okay, and maybe you will see more. So high-rise buildings, they have some common problems, especially in the environment of Bahrain because we are very close to sea. Okay, so in this environment, the high-rise buildings, they face a lot of wind loads. Okay, so wind, yes, if you have gone to a high-rise building and stood in the window or the gallery or the roof, you can feel the force of the wind. Okay, and imagine your building is constantly under that much load, constantly. Okay, so the high-rise buildings and the coastal areas, areas like Bahrain, they face very high wind loads. We know about the temperature, right? Temperature now, alhamdulillah, temperature is very very good, very bearable, enjoyable actually. But in most times of the year, the temperature is very high. Okay, it gets higher than most of the countries in the world. Okay, so the building has to withstand those temperatures as well. And then we have the humidity aspect. Okay, with humidity, then you have the moisture. Okay, humidity deals with the moisture in the air, and moisture is not good for structures. Okay, moisture is not good for structures. So moisture in the air, moisture by rain, whatever. Okay, inside, outside, it can damage the structure. So a structural engineer who is designing a high-rise building in Bahrain has to take into account these factors. Okay, wind loads and high temperatures and humidity and how it should be taken into account in the design. So the structural engineer has to make sure the building can withstand the immense heat and the high wind pressure, and he should use a material which can sustain corrosion and salinity. Okay, this is a problem with the winds which are in the coastal areas. Okay, the coastal areas winds, and I talked about humidity as well. Okay, and even the ground conditions. The ground conditions are saline. Okay, when we say something is saline, what do we mean? You may have heard about saline water as well. So salinity means what? If something is saline, it contains what? Saline materials, salinity contains what? Tell me. Salt, yes. Okay, so because we are close to sea, so the wind as well as the groundwater and even the soil may have salts in it. And these salts, when they interact with the any metal, especially steel, the one which we use, okay, sodium, very good. You will become a scientist after you graduate, right? So this can cause corrosion to the okay, so this salinity will cause corrosion to the steel. Okay, so and the structural engineer, as I said, he has to take into account the load, and the building cannot bear the load. That means the building is unsafe. Okay, dissolved gases, I don't know. Maybe, I don't know. Okay, if we have a 10-story residential building in Manama, okay, uh, what factors should we consider? The factors which I already mentioned. Okay, can you think about any other factor that we need to consider for a 10-story building in Manama? 10-story means it's a uh, high-rise building. Okay, so if you are the structural engineer and you are designing a 10-story building in Manama, what are the factors you need to keep in your mind? Any specific factors? Some of the factors I already mentioned, right? Some of the factors I already mentioned. Can you think about anything else which you will consider for your design? Yes, a structural engineer should consider what? The wind, weather, and terrain. Okay, what else? Think like a client. Okay, if you are the client, what would you have in your mind if it's your building? Soil condition very important. Okay, strength of the building, meaning materials you use in the building. Okay, how much loads you are having. Okay, okay, so good enough. This is like a complete chart, but you can see it contains most of the things we discussed earlier. Wind loads. Okay, so as a structural engineer, you need to calculate the wind loads. You have to make sure that these wind loads can be borne by the building. Okay, the building can take this window with these loads. Okay, and you have to make sure that the wind does not cause the building to deflect too much. Okay, it does not destabilize the building. Okay, so the you have to calculate the wind load. You have to make the building strong enough to take the wind load, and you have to make sure that the wind does not cause, so wind is not causing the building to collapse, but it may cause the building to deflect from its position. And the deflection is too much, then it will be discomfort for the people, okay, who are living in the building. Okay, then we have the temperature effects. We talked about it, and temperature goes up and down. Okay, so the thing which I missed earlier, uh, in many cases, you see cracks in the building not because of very high or very low temperature, but because of the variation of the temperature. Okay, so you know when temperature is high, things expand. When temperature reduces, things contract. So when we are talking about solid materials, okay, we are not talking about water or something. We are talking about solid concrete or wood or something, and they are interconnected. So at these joints, when things expand and contract, you will see the cracks appearing at these joints. Okay, so we have to take into account how to design these joints as well, and what are the temperature variations and so on and so forth. Okay, then we have the selection of the material. We have a coastal environment, we have salinity in the air, salinity in the water, salinity in the soil. Okay, so you have to use material which can uh, take into or which can resist this saline attack. Okay, this salt attack. Okay, and can withstand for longer time, and at the same time you have to make sure that it is economically feasible as well. Don't go for materials which your client cannot buy. Okay, or which will take like 2 months to come to Bahrain. You have to take into account safety as well. Top priority, we have mentioned it a couple of times earlier. Okay, safety means building should be able to take the loads. Fire resistance. Okay, very important aspect. Fire resistance. You have to make sure that the building, if there's a fire in the building, the fire does not spread very quickly. And you may have seen the footages of buildings, maybe footages of 9/11 or something. So I'm not talking about the event itself, but in case of fire, okay, if you are using material which can not hold under high temperature, it will collapse quickly. Okay, so for concrete, fire resistance is quite heavy. The fire does not spread very quickly. Okay, and the concrete does not melt. So for example, if you are using plastic, okay, plastic under heavy temperature melts very quickly. Okay, so it does not have any fire resistance. Concrete on the other hand has more fire resistance. Okay, wood has less fire resistance than concrete. If you are using wood, it will catch fire very quickly. Okay, So these are the aspects which you have to consider. Okay, and safe evacuation routes if fire happens, any emergency happens, how people will come out of the building, the cost of the building. Okay, the last thing is you have to consider the cost of the building. And as I mentioned, you have to balance between quality, safety, and cost. Okay, and I already gave the example of material. Material could be very good, but very costly. So you have to balance. Okay, but you have to make sure that it's not unacceptable or unsafe. Okay, you do not reduce the cost so much that it becomes unacceptable or unsafe for the client. Okay, so if you make any wrong choices in geotechnical engineering, you do any mistake in the analysis of the soil, it can cause settlement. I already gave the example of settlement, or it may cause cracks in your foundation or the building, or it can cause a complete failure. Okay, you may have heard about the Tower of Pisa, right? Okay, it's in Italy or something, right? So it's the leaning, right? It's leaning. Why it's leaning is mainly because of the problem with the soil. Okay, so you can see the whole tower is bending, it's leaning. Okay, it's falling something. So it's the consequence of the geotechnical engineering aspect. Okay, you can see the whole building is tilting, the whole structure is tilting just because of the problem with the soil. Okay, and the main point is the soil conditions are not same everywhere. So even within Bahrain, even within a city, the soil conditions can change. The soil condition can change at one place when you go from 1 meter depth to 1.5 meter depth. Okay, so even on the same place, as you go down into the soil conditions can change. So that's a very big challenge. Okay, no assumptions here, no assumptions are true here, that I did the soil test here at 1 meter, it will be the same at 2 meters as well. Or I did the soil test at place A and I have another project in the next plot at place B and it will be the same soil. There's no guarantee for that. Okay, in Bahrain we have soil, the natural soil is sandy because we are close to sea, and we are doing a lot of construction on reclaimed soils. The Al Muharraq, the new Sitra Island, and whatnot. You already know the projects. These are on reclaimed soils. Okay, so their bearing capacity is usually lower than the natural soil. So you have to consider that into your design as well. Okay, so you cannot. So it will affect mainly the foundation design. The foundation design. Geotechnical engineering mainly affects the design of the foundation. So design of the foundation should be according to the soil properties and behavior. So a small question here, the last question before we, and you can go through it later on. Okay, but can we use the same soil for reclaimed sand and the natural sand? Is it possible to use the same soil for reclaimed and natural soil? I will post it as a poll here. Yes. So you can see the poll over there. You can say yes or no. And this is the last thing. We will stop here after this. Somebody says yes, no, okay. Change your mind. Okay, very well. So you get the point. You understand the problems, okay, and how it can be effective for Bahrain. Okay, I'll go for the attendance. Attendance, as I said, will be through the QR code. You can see the QR code over here. I stop the recording.